How does oscilloscope bandwidth affect your measurements? Imagine trying to listen to a fast-paced song with earphones that only pick up the bass. You miss the high notes and the quick beats. That's similar to what happens when an oscilloscope's bandwidth isn't high enough to catch fast signals. Oscilloscope bandwidth is the range of frequencies it can accurately measure and show. It is usually marked as the frequency, where the signal's amplitude drops to about 70.7% of its true value. If the bandwidth is too low, the oscilloscope can't display the high-frequency parts of a signal properly. This causes the waveform to look rounded or distorted, especially at the edges. For example, a square wave has sharp edges made of many high-frequency harmonics. If the bandwidth can't handle those, the edges will look smooth or rounded, and the amplitude might seem smaller than it really is. This makes it hard to measure how quickly the signal rises or falls. In electrical engineering, there is a rule called the 5 times rule. It says the oscilloscope bandwidth should be at least 5 times higher than the highest frequency in your signal. This helps ensure your measurements are accurate within about 2%. The bandwidth also affects how fast a signal's rise time can be measured. Rise time is how quickly a signal changes from low to high. The faster the rise time, the higher the bandwidth needed. For example, if you want to measure a signal that rises in 500 picoseconds, you need an oscilloscope with a bandwidth of around 1 gigahertz or more. If the bandwidth is too low, you won't see the true speed of the signal. The probe you use also matters. The probe's bandwidth should match or exceed the oscilloscope's bandwidth. If the probe's bandwidth is lower, it will limit the overall measurement accuracy. Using a low bandwidth probe on a high bandwidth scope can cause the signal to be attenuated or distorted. When the bandwidth isn't enough, you might see the signal's amplitude appear smaller, the waveform edges look rounded, and timing measurements like rise time or pulse width become inaccurate. This can lead to misinterpreting high-speed digital signals, serial data, or video signals. To get reliable measurements, it is important to choose an oscilloscope and probe with the right bandwidth for your signals. Higher bandwidth scopes can capture faster signals with more detail, but they tend to cost more and be more complex to operate. Balancing your measurement needs with your budget and the signals you work with is key. In short, if your oscilloscope's bandwidth is too low, your measurements will be less accurate, and you might miss important details of fast signals. Picking the right bandwidth ensures you see the true shape, amplitude, and timing of your signals, making your electrical measurements trustworthy.